Morning, team. All right, so here we have the microscopic view of the compact bone. Okay, so this is what we talked about yesterday. And you can see here we have these osteons, right? So these osteons or Hervetian systems, what they do is they are like the pillars. Okay, so those are the pillars that I'm talking about. So when you see compact bone, if we can just quickly scan up to the long bone. So we see the compact bone sits around the outside of the medulla cavity within the diaphysis. Okay, and so you can imagine that around here we have all these pillar-like structures, just like if you picture what the sky tower looks like, is that it's hollow on the inside, but then around the outside, if I can use my speaker as an example, it will be hollow on the inside, but around the outside you'll have these big pillars, right? Big pillars around the outside to provide it with a lot of strength. Okay, and those pillars are called osteons. Or they're also known as the Hervetian system, okay, which is that idea of pillars within the compact bone. Now, within those pillars, we can see that we have blood vessels, all right? So you have blood vessels that run through there, but then within the actual circle, the actual pillar, okay, it breaks down into what looks like this, all right? So we would have a lamella. We would then have osteocytes, lamella, osteocytes, lamella, osteocytes, lamella. Okay, and through the through each of the lamella, what you also have is you have these canalculus, which are little vessels, little canals to help the blood run between the osteocytes. Now again, if we go back up to our bones, okay, and we look here and we see osteocytes. So osteocytes are that mature bone cell. So yesterday when we talked about the mature bone cells are the ones that have been already formed and are already set. Okay, so when we're looking at that microscopic view of the pillar, those osteocytes that sit in between the lamella are already formed mature bone cells. So it's the strongest part of the bone, these osteons, right? The Hervetian system, and they run out. And then what we have is we have these little hollows, okay, which are, let's see if we can get wrong way. Okay, so each Hervetian system consists of rings, okay, or little plates. That's what we talked about. And in between each of the rings, we have osteocytes or mature bone cells. Now, they don't sit like, it's not like a complete layer. What it is it's like hollowed out areas around it, and that's where the osteocytes sit in. And those hollows, you can see that there's a little hollow here, a little hollow here, a little hollow here. And what they do is within those hollows, those hollows are called lacunae, right? And so within the lacunae sit the osteocytes. And then between each of the lacunae, we have little vessels, okay? And these little vessels are called canalculus, right? And they link the other lacunae and the osteocytes to one another so that they can pass osteocytes and stuff back and forth between them, right? And then we have the blood vessels that would then run from inside the spongy bone, where the yellow marrow is, into the osteon, right? And that's how we're able to get the blood from the spongy bone into the so the bone marrow into the bloodstream into the body. Right, so this is our microscopic view of what the compact and spongy bone looks like. So just to recap, an osteocyte is a mature bone cell. A lamella is a ring. The lacuna are the hollowed out areas in between each of the lamellar rings. The canuculus is the little vessels that go between each of the lacuna and the osteocytes to link them all together. Altogether, that whole system makes up the Hervetian system, also known as an osteon. All right, and that osteon, that Hervetian system, is a pillar, a pillar-like structure that sits running up and down the bone around the medullary cavity, to provide it with strength. Okay, and what it also does is it's the home for those blood vessels to run through from the spongy bone out into the body. Okay, so big pillars, blood vessels, rings, little hollowed out areas, mature bone cells. All right, team, hopefully that helps.